The C83400 red brass rod AB and 2014 T6 aluminum rod BC are joined at the color B, and they are fixed connected at their ends. We know that there is no load in the members when the temperature is 10 centigrades. Our goal is to determine the average normal stress in each member when the temperature is 45 degrees. Furthermore, we would like to find that how far will the color B will be displaced. Let's start with the material constants. You can find these material properties in your book. For brass, we have Young's modulus. I will write EB so that we can differentiate. Is equal to 101 GPa. And coefficient of thermal expansion is 18 times 10 to the power of 6 1 over centigrade degrees. And for aluminum, we have the Young's modulus is equal to 73.1 GPa, and we have the coefficient of thermal expansion is equal to 23 times 10 to the power of minus 6, again 1 over centigrade degrees. And also we know their cross-sectional areas. Let's start with our observations first. We know that force on the rod AB should be equal to the force on BC. I will write FA for the aluminum rod and FB for the brass rod. And let's say that the force is equal to F. Also, we know that the displacement from A to C will be 0 because their ends are fixed. We have the formula for change in length, which is delta L is equal to alpha times the initial length times the temperature change. And also we know the areas are equal, so the cross-sectional area of AB is equal to the cross-sectional area of BC, and let's say that they are equal to A. Now, we can start solving then. We will start with this term here. We know that the total displacement will be 0. Let's write its equation. We know that displacement from A to C is equal to the force times length of AB over EB times the area plus alpha B delta T and again the length of the rod AB. Also minus F LBC over EA times ABC plus similarly alpha A delta T and LBC. And this is equal to 0. We know the lengths, we know the Young's modulus values for the rods, and we also know areas, we know alpha values, we know the change in temperature, so we can solve this equation for F. And our last term is and this is equal to 0. When we solve for f, we get f is equal to 69.45 kilonewtons. Since we know f and the area, we can now calculate the stress. We know that stress is equal to F over A, and it is equal to 69.45 kilonewtons over 1130 millimeters square. And from this equation we get sigma is equal to 61.46 MPa. Now, we also would like to find the displacement of the color. We can say that the displacement of the color will be from A to B, and it will be equal to F LAB over EB times AAB plus alpha B times delta T times LAB. And when you substitute the values, you will get displacement from A to B is equal to 21.47 times 10 to the power of minus 6 meters. And this is equal to the displacement of the color.